Good morning, students. Today we will start the new chapter from the physical chemistry part. So the numericals are asked for the examination from this chapter. It is having the weightage 4 marks and with option is 6. Now write your seat number and name in the chat box. We will wait for 30 seconds and we will start. Yes. So it is a chapter number 2 from the physical chemistry part. Name of the chapter is Solutions. In previous syllabus, the name of the chapter was Solutions and Colligative Properties, but now the name of the chapter is changed and many concepts are changed from this chapter. It is having weightage 6 marks out of 98 and 4 marks out of 70. First, we will discuss some general terms, that is introduction. This is asked for examination for 1 mark. So solution is what we will discuss first. Solution is nothing but these concepts are already completed in school days also. Solution is a homogeneous mixture, remember. It is a homogeneous mixture of 2 or more pure substances. We know what is mean by homogeneous and what is mean by heterogeneous. So remember, a solution is always a homogeneous mixture of 2 or more pure substances. A true solution consists of a solvent and 1 or more solutes are there. So what is mean by solvent, what is mean by solutes, we will discuss in shortly, and we will start the next part. So solute is what? Solute is nothing but it is a component that dissolves and constitutes a smaller proportion of the solution. Means in solution, suppose if you take the solution of water and sugar and salt, so it is a solution of sugar, water and salt. In this, the sugar and salts are treated as solutes and the water acts as a solvent. So solvent, it is present in larger proportion, and solute, it is present in smaller proportion. Such type of system is called a solution. So in case of solution, the solute and solvent may be different. It may be solid, liquid or gas. So depending upon the solute and solvent, solute may be solid, may be liquid or may be gas. Also the solvent may be solid, liquid or gas. So depending upon the nature of the solutes and solvents, there are 9 types of solutions, remember. Before this, we didn't study these types of solutions. We know only solutes are solids and solvents are liquid. But today we will discuss there are liquid solutes also, there are gaseous solutes also, and solvents also solid, solvents also liquid, solvent also gas. So depending upon this, there are 9 types of systems are there. So we will discuss one by one how these 9 types of systems are uh, included. So this is a first column. Serial number is shown. It is the second column is state of the solute. See the state of the solute. First three are solid, then second three are liquid, and this is gas. So state of solute, it is present in smaller proportion in the solution, and this is the state of solvent, which is present in larger proportion. This is also liquid, solid, gas, liquid, solid, gas, liquid, solid, gas, and we will see these examples one by one. So first we will take example of solid liquid, means the solute is solid and the solvent is liquid. This is very common. Sea water, as you know, in sea water, there are many salts are dissolved. These salts are present in solid form. Then benzoic acid in benzene. Benzoic acid is solid and benzene is liquid. So this is a good example of solid and liquid. Then sugar in water, just already I have explained sugar in water. So sugar is solid and the water is liquid. Then second type of solution is solid solid. Both are solids, means solute is also solid and solvent is also solid. Such type of examples are metal alloys. You know this word alloy, what is mean by alloys? It is a mixture of two or more metals are there. It is called as alloys, such as brass, bronze, in which both solute and solvents are both are in solid state. Then solute is solid and solvent is gas. This is iodine in water. See, iodine is in solid form, and this is a air is in gaseous form. So this is a very nice example of solid and gas system. Then we are coming to the liquid solute now. Both are liquid. Solvent is also liquid and solute is also liquid. Examples of such type of systems are gasoline, then ethanol in water. Ethanol is also in liquid state and water is also in a liquid state. Then liquid and solid. State of the solute is a liquid and it is solid. So this amalgams also I have explained in the chapter number 12, aldehyde ketones and carboxylic acids. So amalgams means when the metal is combined with mercury, it is called as amalgams, remember. So mercury is a solute here. See, mercury is a liquid solute and metals are here, metals are solid, solvents are there. So the examples we can take zinc amalgam, mercury in silver, it is silver amalgam. So when any metal is combined with mercury, it is called as amalgams, remember. So next type of system is liquid and gas. Solute is a liquid and solvent is gas. It is a chloroform in nitrogen. See, chloroform it is in liquid state and nitrogen it is in gaseous state. So the system is liquid and gas. Solute is liquid and solvent is gas. Then next type is gas and liquid. A solute is gas and a solvent is liquid. So the good example is carbonated water. All of you are familiar with this carbonated water. It is present in soda and many beverages. It is a mixture of carbon dioxide and water. It is called as carbonated water. It is acidic in condition. So in this carbonated water, gas, that is carbon dioxide, acts as a solute and water acts as a liquid. Also oxygen in water, here also again oxygen is a solute and water is solvent. Then next type of system is gas and liquid. Gas is a solute and solid is a solvent. So H2 palladium. See here, H2 is a gas which acts as a solute, and palladium, it is a metal, or platinum, we can take platinum or palladium. This is used as a catalyst in catalytic hydrogenation. So hydrogenation reaction. In many reactions, we already discussed this H2 platinum and H2 palladium. So H2 is a gas, and state of the solid is palladium metal or platinum metal is used here. Then last system is both are gas. It means solute is also gas and solvent is also gas. So such type of so examples of such type of system is air. See, in air, all the gases are present: oxygen, nitrogen, then argon, other gases are present. Means both solute and solvents are both are gas. So this table is very important because 1 mark question will be asked on it. Remember. So that's why it is not eliminated, not deleted. Purposefully, it is kept in the syllabus in the COVID-19 situation also. So remember, this table is very important for 1 mark. 1 mark question will be asked. They will ask, write the example of liquid, write the example of liquid gas. So any example, they will give the example also, and they will ask, write the name of the solute and write the name of the solvent. So be careful regarding the studies of this table. Then next part, it is a different types of solutions depend upon the amount of solute dissolved. So there are 3 types of solutions. One is a saturated solution, the second one is unsaturated solution, and third one is supersaturated solutions. I think you are familiar with these words: saturated, unsaturated, and supersaturated. So one by one we will discuss the definitions of this saturated, unsaturated, and supersaturated. See what is meant by saturated solution. The word saturated is familiar with you. Saturated means the saturated. First, we will discuss the saturated solution. Saturation means there are many pupils are there. Like we in a general day-to-day life, we oftenly use this word saturated. Saturation means many pupils are present. For example, engineering saturation is there, means many students are doing the engineer. So saturation, this word, it is actually from this saturated solution. So saturated solution I will discuss now. The solution contains maximum amount of solute. See, the saturated solution means it contains the maximum amount of solute dissolved in a given amount of solvent. Means we can't further dissolve any amount of solute in it. Then the solution will be supersaturated. So maximum amount of solute means we can't dissolve further solute in the solvent. We can do this experiment at your home. Take water in a glass, and slowly we have to dissolve. Slowly we have to dissolve the salt, or we can dissolve the sugar also. First we have to take a glass, first take little amount of sugar or little amount of salt, dissolve it, add it, dissolve it, stir it. So one stage will appear like this. We can't dissolve further solute. So such type of state is called as saturated solution. Remember. So in case of saturated solution, this rate we can see here, the rate of dissolution is equal to the rate of crystallization. Means whatever we are going to dissolve, whatever amount of solute we are going to dissolve, and the rate of crystallization will be same. It will be crystallized. So remember this definition of saturated solution. This may be asked for 1 mark. Then I am coming to the unsaturated solution. So unsaturated solution, it is exactly opposite to the saturated solution. Means we can dissolve the solute. So unsaturated solution is one in which more solute can be dissolved at a given temperature. Means we can dissolve the solute in this unsaturated solution, but we can't dissolve the solute. Maximum amount of solute is already dissolved in case of saturated solution. Means unsaturated solution we can make saturated by dissolving the solute. See here, there is no equilibrium exists between a dissolution and crystallization. And third one is supersaturated solution. Actually, this supersaturated solution contains very greater amount of solute is there. Actually, means it is higher than the saturated solution. Supersaturated. This word indicates there is a excess amount of solute is there. The solution containing greater than the amount of solute means whatever the amount of solute required for saturated, इससे ज़्यादा solute present होता है इसमें super saturated solution. So this solution is very unstable. Why this is unstable? Because if a little very tiny, this tiny word is used here, if a tiny crystal of solute is added to the supersaturated solution, precipitation occurs. Means very little amount of if solute is added in supersaturated solution, immediately precipitation takes place. Already the amount of solute is very higher. That's why it is called as supersaturated solution. And from this we can clearly remember rate of crystallization is more here. See, means if a little amount of solute is added, it becomes crystallized. So rate of crystallization is higher than the rate of dissolution. So supersaturated solution changes to the saturated solution. So these definitions ask for 1 mark. Forget about this rate of dissolution. This is given for your understanding purpose. But for the examination, we have to write the definition of this saturated solution, unsaturated solution, and supersaturated solution. And these are very basic concepts we can easily remember. Then I am coming to the solubility now. Solubility, it is nothing but the amount of solute dissolved in a solvent at a specific temperature. It is called as solubility of a solute, remember. So again, the definition is very important here. What is meant by solubility? Solubility means it is the amount of solute per unit volume of saturated solution at a specific temperature. It is called as solubility. In simple words, amount of solute dissolved in a specific amount of solvent, it is called as solubility. But this is a scientific definition I have given, and for understanding purpose, you know, amount of solute, it is dissolved in particular amount of solvent to form a saturated solution. It is called as solubility. And solubility, it is measured in moles per liter. It is measured in moles per liter. There are some factors which affects the solubility. First one is the nature of solute and solvent. You know, the solutes and solvents like dissolve likes. Remember this statement. Like dissolves, like means polar solutes dissolved in polar solvents, and non-polar solutes dissolved in non-polar solvents. I will give the examples here. See why such type of situation is there. Polar solutes dissolved in polar solvents and non-polar solutes dissolved in non-polar solvents, because there is a solute-solute interactions are there. Solute-solute, solute-solvent and solvent-solvent interactions are there. We will take one example of NaCl. See, NaCl is a polar solute, solid solute, and it dissolves in water. Water is also polar. So why this dissolves? I will give the reasons. NaCl dissolves in water because it is also polar, and this is also polar. Both NaCl and water both are polar. So in NaCl solution, there are 3 types of interactions are there. So which are these 3 types of interactions? See, strong ion dipole interactions of Na plus and Cl minus ions in water is present. Second one is hydrogen bonding of water molecules is present. And third one is ion-ion interactions between Na plus and Cl minus are present. So these type of interactions are present in non-polar also. But there are another types of interactions. It is not required to remember these reasons, but you should know polar dissolves in polar because of these interactions are there. So we will take one example of non-polar also. Non-polar organic compounds like one example is there, cholesterol. Cholesterol is non-polar, it dissolves in non-polar solvent like benzene, then alcohol, all these, sorry, benzene, hexane, all these are non-polar. Ether also non-polar. So one more example is given here. Sugar dissolves in water due to the intermolecular hydrogen bonding between sugar and water. So nature of solute and solvent is also affects the solubility. Polar solute dissolved in polar solvent, non-polar solute dissolved in non-polar solvent. Then second one is effect of temperature. This may be asked for 1 mark. The question will be like this. What is the effect of nature of solute and solvent on the solubility? So 1 mark question can be stated on this part. What is the effect of solute and solvent on the solubility? So we have to write this likes dissolves like polar dissolves in polar solvents. Then next one, effect of temperature on the solubility. We know the solubility changes with temperature. Generally, solubility increases with increase in temperature, but this is not always true. We will take one example. Endothermic and exothermic process. Endothermic means there is absorption of heat, and exothermic means there is a release of heat. So we will take these 2 examples here. See here, I will take the directly example. KCl dissolves in water. KCl is a potassium chloride which is dissolves in water by endothermic process. Means when KCl is dissolved in water, heat is absorbed and its solubility also increases with temperature. Means the solution of this KCl and water, if this is heated, solubility will be more. This is an endothermic reaction. Opposite to this endothermic, there is one exothermic reaction. I will explain. Exothermic means heat is evolved here. So solubility decreases with increase in temperature here. Remember this one. In case of exothermic processes, solubility decreases with increase in temperature. These are the exceptional cases. Calcium chloride, lithium sulfate, when these are dissolved in water. When these are dissolved in water, heat is released and the solubility decreases with rise in temperature. So these are the 2 examples. When these are dissolved in water, they releases heat. Exothermic reaction takes place and their solubility decreases with increase in temperature, remember. So the question will be asked for board exam. Write any 2 examples or write any 2 substances whose solubility decreases with increase in temperature. So remember, same these 2 are also included in your textbook also, in your syllabus also. So in fact, there is no direct correlation between solubility and exothermicity or endothermicity. Some solutes solubility increases with increase in temperature, and some solutes solubility decreases with increase in temperature. So there is no direct correlation between solubility and exothermicity or endothermicity. Another one example is given, say the dissolution of calcium chloride is exothermic and that of NH4NO3 is endothermic. The solubility of both the compounds increases with temperature. See here in this example we already discussed this. When calcium chloride dissolved in water, it is a exothermic, and that of NH4NO3 is endothermic. but the solubility of both the compounds increases with temperature. See, the solubility increases with increase in temperature, means there is no any relation of exothermic and endothermic. There are some solutes whose solubility is also increases. So next part is the solubility of gases in water usually decreases with increase of temperature. In case of gases, remember the solubility of gases when the gaseous solutes are used, when gaseous solutes dissolved in water, its solubility generally decreases. When the temperature is increased, solubility decreases, remember. So these are the reasons why it is happening. When gases are dissolved in water, the gas molecules in a liquid phase are condensed. So we can do this experiment at your home. We know, I think this example is given. The example is not given. I will explain. See. So when the gases are dissolved in water, the gas molecules in liquid phase are condensed. Means when the temperature is increased, the solubility is decreased because the gaseous molecules also escapes from the water or from the solvent. So the condensation is an exothermic process. You know, the condensation is exothermic process because in condensation heat is evolved. So solubility of the gases must be decreased according to this exothermic. In exothermic reaction, we can see if the dissolution is the exothermic, solubility decreases with increase in temperature. So we can observe this example in case of summer. In case of summer season, the aquatic fish prefers to stay at the lower side of the pond or lower side of the water, because in case of summer season, what is happening actually due to the temperature, due to the more temperature, what is happening, the dissolved oxygen on the surface is already evolved. So it is very difficult to get the oxygen for the aquatic fishes also, or tortoise also. So the aquatic system prefers to stay at lower portion, means at lower side of the water. This is a good example of this effect of temperature on the solubility, because in summer season, the dissolved oxygen on the surface, it is already evaporated. So this question may be asked for application purpose, why the aquatic fishes or tortoise prefers to stay at lower side of the pond in summer season. Then what is the effect of pressure on the solubility, we will discuss. Uh, Pressure has no effect on the solubilities of solids and liquids, as they are incompressible. Means pressure doesn't affect the solubility if the solid and liquid solutes are there. They doesn't affect because they are incompressible. We can't compress solids and liquids, but we can compress the gases also. So the solubility of the gases, again, the solubility of the gases increases with increase in pressure. So this relation is given by one scientist. What is the relation between the gas and pressure? So relation is given by this famous scientist Henry. So what this Henry's law is stated, it states that solubility of a gas, remember, solubility of a gas in a liquid at a given temperature is directly proportional to the pressure of the gas. Means directly proportional indicates solubility of a gas in liquid increases with pressure. So we can write S is equal to KHP, where this KH is a proportionality constant. It is also called as Henry's law constant. So this S is directly proportional to P. This is written as S is equal to KP. Actually, this is KH. KH is nothing but Henry's law constant. This is equation number 2.1, where the solubility, solubility is measured in moles per liter, and where P is the pressure of the gas in bar. This is unit. So the unit of this solubility is moles per liter, and the unit of pressure is bars. So what is this unit of KH? I will explain here. KH is equal to this P, uh, by rearranging this equation number 2.1, KH is equal to S divided by P. This P is shifted to this side. So what is the unit of solubility here? Moles per liter divided by the bar. Bar is unit of this pressure. So unit will be moles per liter per bar. That is moles liter inverse and bar inverse. This unit maybe as for 1 mark, write the unit of Henry's constant, and this Henry's law is also asked for 1 mark, write the statement. So remember this statement. Henry's law states solubility of a gas in liquid is directly proportional to P. S is directly proportional to P. Remember this statement. So we will get 1 mark. S is proportional to P. When the pressure is 1 bar and when P is equal to 1, so KH is equal to S. This when this P is 1 bar, so this solubility is equal to the constant. So KH is the solubility of the gas in liquid when its pressure over the solution is 1 bar. Means this solubility is equal to the constant when this is possible, when this P is 1. So I think you understand what is the effect of so these are the effects of factors affecting on the solubility. Number 1, we discussed this is the nature of solute and solvent. Number 2, we discussed the temperature. Means temperature actually doesn't affects in case of some solutes, temperature, if temperature is increased, solubility is increased, but in some cases, if the temperature is increased, solubility is also decreased. Remember, these two exceptional cases are there. And what is the effect of pressure? If the pressure increases, solubility of gas is affected, and it is given by the Henry's law. But pressure doesn't affect in the solubilities of solids and gases. Then, yes, this example, you must know this example. Why effervescence comes out when the cap of sealed carbonated soft drink beverages bottle is removed. So, if you understand the solubility and the gas relation, we can give this answer. Why effervescence comes out when the cap of sealed carbonated soft drink bottle is removed. So this is happen because carbon dioxide is more dissolved with pressure in the carbonated drinks. So it is explained in detail. This is happening because the bottle of carbonated soft drinks beverage is pressurized by a mixture of carbon dioxide and air. Means in that bottle, carbon dioxide and air mixture is already pressurized. Means with pressure it is what you can say, it is installed in this. So due to the high pressure, what is happening, as you know, according to the Henry's law, the solubility of the gas in liquid increases with pressure. So due to the high pressure, this carbon dioxide, amount of carbon dioxide dissolved in dissolved state is very, very high. So what happens when the pressure is released? When we remove the cap, the pressure immediately it will be released, and the dissolved carbon dioxide, it will comes out with the form of effervescence. So also the effervescence also comes out. So when the cap is removed, the excess of carbon dioxide and air, it is sealed in a sealed bottle, it is escapes, and external pressure is also decreases. So the solubility of carbon dioxide, it will decrease by escaping and we will see the effervescence as the carbon dioxide comes out. So this is application level question. It may be as for examination. So in this diagram, it is also illustration of Henry's law is shown here. See here, this is one flask lower pressure of the gas which is having lower solubility, and we can see here higher pressure of the gas, it is having higher solubility. See the molecules. See the number of molecules are high, so the pressure is high, the solubility will be high. If the pressure is low, solubility will be also low. Then we will discuss this one example. We will solve one example, and we will start the next. I will today send this PDF of this chapter, because 2-3 slides are remaining. That's why I didn't say send the PDF. After finishing the lecture, I will send the PDF. So we will discuss this one problem. It is depend upon the Henry's law. Now you understand Henry's law, S is directly proportional to P, or S is equal to KHP. By remembering this formula, we can solve this numerical. The solubility of N2 gas, nitrogen gas, in water at 25 degrees Celsius and at 1 bar is 6.85 into 10 raised to minus 4 moles per liter. The solubility is given here. See, the solubility of N2 gas is given, and the temperature is also given. The pressure is also given. And what is asked? Calculate Henry's law constant. Means we have to calculate KH. That is Henry's law constant. Also, we have to calculate number B, the molarity. The molarity, you know, in 11th standard, we already learn about this molarity, number of moles dissolved in per liter. So molarity of the N2 gas dissolved in water under atmospheric condition when the partial pressure of N2 in atmosphere is 0.75 bar. So this numerical is given. What we have to do first, we will write. We have to calculate this Henry's law constant. By knowing this formula, KH is equal to S upon P. According to this formula, KH, say this formula is written here, KH is equal to solubility divided by pressure. The solubility is also given 6.85 into 10 raised to minus 4 moles per dm cube, or it is moles per liter, and divided by the pressure is given 1 bar. All the both the things are given. So this 6.85 divided by 1, it will be 6.85 into 10 raised to minus 4. For calculating this, you will get 1.5 mark, remember. So if the numerical is for 3 marks, by writing this and putting the values and calculation, we get 1.5 mark here. And the second one, we have to calculate the molarity of N2 gas dissolved. See here, S is equal to KHP. S is equal to KH into P. So solubility is equal to the KH into P. Now you know this value. You know the value of this KH now. And the pressure is also given here, 0.75 bars. So what we have to calculate here is molarity of N2 gas. Molarity of N2 gas dissolved in water under atmospheric condition when partial pressure of N2 is 75 bar. So this means we have to calculate the solubility. So KH into P, KH is already known, and this is a atmospheric pressure is given. By multiplying this, we can get this value. So I think we completed today the general terms. Then what is mean by solute, 9 systems, solute, solvent, and also Henry's law. What are the factors affecting on solubility? So I will stop here. I will send the PPT and solve the numericals and go through the notes.